Okay, now members, let us start these regular hexagons. We are going to start with a simple thing, then we move on to something bigger. So a regular polygon, remember here that regular polygon means that all sides are equal. So the side, then this is 4 meters, 4 meters, 4 meters. I have summarized the question for you, but let us go through it. 6 forces, 5 newtons, 6 newtons, 7, 4, 5, and 8 newtons act along the sides. PQ, you see PQ goes with 5, QR with 6, RS with 7, ST with 4, TU with 5, then 8 newtons with UP. With the direction of the forces indicated by the order of letters. Taking PQ as the reference axis, find the magnitude and direction of the resultant force. Now, the only problem we have, these forces are okay. We need now to resolve this into the x and then the horizontal and the vertical component. First of all, you need to find the exterior angle. So this exterior angle here, the sum of exterior angles, this exterior angle is given by this divided by n, the number of sides. So these sides are 6. Divide by 360, you get this as 60 degrees. Now, if this is 660, this one is going to alternate in this way. You can also get it in that way. Also, this one is going to be 60 degrees. Also, this is going to be 60 degrees in that order. So this one will help you when you are resolving. Now, when you study, I'm going to get moments. Always try to resolve these forces inside. In the next example, I'm going to resolve them outside, but here I'm going to focus on resolving them inside. So if this is 60, it means that we are going to get this force and then this force. So to get this force, you know that we shall move like this, up. Then we move like that. So then I move in that order. So because you see that this one is going to be adjacent. So meaning this force here is going to be adjacent in that order. Then I can move like this. So this one is going to be now, you can name this one as 6 cos 60. And then this one is going to be opposite. But I want them inside. So this one is going to be 6 sine 60. When I come to this, you see if this is 60, it means that also this one is going to be 60 degrees. So now I can resolve this alone. When I resolve this, I'm going to be having, or it is going to be coming in this direction. So let me remove this. So this is going to be coming in this direction. But for it to see that now, it's going to be, this is adjacent. It's going to come like that. And then like this. So this one is going to be 7 cos 60. This is going to be 7 sine 60. This is okay. We come to this. We always try to put them inside. So this is going to be, if this is 60, then this one is also going to be 60. So we try to resolve now this. This is where it's coming. You see it's going like this. So mean that all the forces will come. So from here where it's coming from, means that this force is now going to come, then it makes it there. This is going to come like this, then like this. So this one is going to be 5 cos, this is sine because it's the opposite sine, 60. And this is going to be 5 cos 60, it's adjacent. When I come to this, even this one here, it's going to be 60. So trying to resolve now this force here. It's going to be now, it's going to be this side. When I try to resolve it this side, it's going to go there. You see this is adjacent, it will be 8 cos 60. This is going to be opposite, 8 sine 60. Once you finish, you put them inside, only you have moments so that you don't get confused. Okay. Now we can come and get our horizontal components. Resolve in that direction, we're going to be having x equaling 2. Now we have this 5. Then you see this one is going that side. Then plus 6 cos 60 is going in that direction. So this one is opposing. Then minus 7 cos 60. Then minus 4. Then where? You see, we have first of all, we have this one opposing. We have first of all minus 5 cos 60. And then we have this one going like that side. Plus 8 cos 60. Okay, so from here our x is going to be, you see cos 60 the same as a half. So I'm going to be having 5 plus 3 minus 3.5 minus 4, 5 plus 4. So I have 2. My x is 2 meters. And now I try to resolve this vertically. Vertically, what do we have? We have this one. It is going to give us this one, 6 sine 60. Then we have that plus 7 sine 60. Then we have this one minus 5. This one going down minus 5 sine 60. And then this one also going down minus 8 cos 60. I mean sine 60. And then you see our y. You see this one is going to give us this, and this is going to give us 13. And this is going to give us negative 13. Just that all of that is going to reduce to 0. Our resultant, which is going to be equal to 2xy, is going to be 2, 0. Which when you try to draw, you see the x is positive, so this is going to be this. That's what we are going to be with. That's going to be our resultant, 2 newtons. As simple as that, because we don't have any x. This is our resultant. So our resultant is going to be square root of 2 squared plus 0 squared. This will be 2 newtons. Then the angle, remember the angle here we get this over this, which is going to be 0. So it's just is a horizontal acting in the line of PQ. So that's how we get the magnitude and the direction. That's the direction. When we come to part B, the line of action. Our line of action, then minus capital Y, x equal to 0. So we need the moment. So here, be careful with the moment. To get moments, now I need first of all to get this length here. These two lengths here. This one and this one is going to be the same as that one. So if I consider now this, not I'm going to consider this. So if I consider this diagram here. So if I consider that diagram there. Remember, if this is 60, then this one is going to be 30 degrees. Remember, this is going to be my Q, this one is going to be my R. Or you can consider the outside. Okay, remember these ones were 4 meters because it's regular. So it means that if this is adjacent, then this one is going to be 4. This one is opposite, so this one is going to be 4 sine 30. Then this is going to be 4 cos 30. What does it mean? It means that now, this diagram here, orange, this one is going to give us 2 meters. Then this one is going to give us 2 root 3 meters. So that means that orange, our height, this height here is going to be 3 meters, because this is root 3 over 2. Then this is going to be side is a half. So, or is this distance? It's going to be that. Then this one is going to be 2 root 3. Or if you consider this will be the opposite here, which will be 4 sine 60, which will also give you the same. So meaning this one is going to be 2 root 3 from here up to there. Then also from here up to here, up to there, it's going to be 2√3 meters. Once you have now these sides even here, from here up to here, it's going to be 2√3 meters. Then also this one is going to be 2√3 meters. Once you have those sides, you are free to take now your sum. So let us take our moments about we are going to take moments about P. So take moments about P. Remember, whenever I want to be, we take them anti-clockwise because this formula was derived using the anti-clockwise direction. So from there, so that my P is going to be now. If I take now about P, all forces coming to and going away from P, they are going to be having 0. So this will be 0, 5 times 0 because the perpendicular distance is 0. So this one is going to have a moment of 0, this one a moment of 0, this one a moment of 0, and this one is a moment of 0. Because they are coming to P, these ones are going to P. Those coming and going away from P, they have their moments as 0. So what are we remaining with? We are remaining with this one. So see this force. I'm going to have this force is going to be 6 sine 60, then times the perpendicular distance from P, from here up to here, they are 4 units. Then plus, which other force do we have? Remember, we have also the C force. I think we can see it. This one, this force here, the one for cos. But now, if I come here, it means that this force is going to be 7. The force here, you see this force from here. Remember, from here, I have 7 cos 60 times the perpendicular distance from this. The perpendicular distance, let me use this and you can able to see it properly. I think you can see this force. This force is like that. So the perpendicular distance from here up to here is 2√3. Then plus. We also have this one, but this one is the acting. So it means that this one is going to be 7 sine 60 times the perpendicular distance from here up to here. So this is the line, I think it's the line of action is this. So from here up to here, it's going to be now 7 sine 60, then times 4. Then plus, what else do we have? You see now we also have this. I think you see this force here. So here I'm going to be having the force of, is it now? You see, these ones we are all of these ones we are going clockwise. I think you can see. I'm going anti-clockwise. If I base on this one is going anti-clockwise. This one sine 60 anti-clockwise. This one is going also anti-clockwise. Let me show you. This 7 cos 60 from here is going anti-clockwise. Then even this one, it was going clockwise. Anti-clockwise. Then this one, when I base it there, it's also going to go anti-clockwise. So it's going to be 4 times the perpendicular distance. You see the perpendicular distance of this force from here. We are going to add this plus this. We are going to say this plus this times 4√3. Then plus. We have now, which other force do we have? I hope you can look at this force here. This force here. This one is the 5. Yeah, 5 cos 60. You see 5 cos 60 is going this side, but this perpendicular distance is going to be here. So it's going to be 2, 3. So I'm going to be adding there 5 cos 60, then times the perpendicular distance. You see, this is the force I'm talking about. This one going this side, this one. So see the perpendicular distance from this point from here up to here. This is the 2√3. So times 2√3. So what else? Now this one is coming. That one is going to be having 0 moment. Then also this one 8 is coming there. It's going to be having 0 moment. Then I have this one here. I think we can see this one for this one 8 cos 60. So plus, you see cos 60, it's going to be, if I put this, it's going to be now acting clockwise. I think we can see this 8 cos 60 is there. So plus 8 cos 60, but this one is going to be negative, minus cos 60, then times the perpendicular distance times 2 root 3, and that's what we are going to be adding. So here our g is going to be, okay, so here, okay, let me write it at once so that we can simplify our lines. This is going to be 24 root 3 over 2, then plus, this is going to be 7, because our half is going to cancel, so 7 root 3, then plus, this is going to be 28 root 3 over 2, then plus 16 root 3, then plus 5 root 3, this one, because this half is going to cancel, then plus, this is going to be 8 root 3. And so from here, our g, let me show you here, I'll get our g. Sorry, this is negative, this is negative, so this is negative from here. So this is going to be 12 root 3 plus 7 root 3 plus 14 root 3 plus 16 root 3 plus 5 root 3 minus 8 root 3. So our g here, use, as I was showing you, I think you can see, if I can take only the coefficients, then I'm going to include root 3 there. So if I include root 3 here, I have 12, I have 46 root 3. I have this as 46 root 3 Newton meter. So now, putting in our formula that our g is equal, we can put in this formula direct, or we can use our x, y, here capital. Okay, so here our g is going to be x, y. Remember this was, the x component is 2, the y component is 0. And then our g here will go to 46 root 3. So here 46 root 3 is going to be, this time this is 0 minus 2y. So when I take this side, when I divide through my y, it's going to be negative 23 root 3. As simple as that. So that's the line of action of our resultant force. So that's how we handle that. I wish you well. I think you can see, if I use this, if I substitute this formula direct, our capital X here was 2, then our capital Y was 0, and I put in here, and then you simplify, we are going to get the same answer. So, you either use this or this, up to you. I wish you well.